Okay, Assalamualaikum, everyone, and good night to you guys. Hello. Okay, how are you guys? Huh? I'm doing fine, thank you. Okay, so okay, eh, okay. Can you guys see the slide? Okay. Hello guys. So for uh, okay, so right now our group going to present integration of function. Uh, so for this session, we're gonna have four presenter. Uh, First is our teacher Cikgu Mimi, Cikgu Minazira. Second, uh, Cikgu Nurliana, Cikgu Nurul Amira, and me, Nur Hidayah. So for our topic, integration of function, then we're gonna have two outcomes, learning outcomes. That is, at the end of the session, I hope all students will be able to determine the integral of exponential function and also to determine the integral of natural logarithmic function. Okay, so for the definition of integration of function, um, integration of function is the process of evaluating an indefinite integral or a definite integral. Sorry. For integral, you can use it to find areas, volumes, center point, and also area under the graph of function. Like you see from the picture shown over here. Okay. Do you guys understand from here? Can you guys? Can some of you answer me? Hello.
Yes, can.
So, integral have two types. One is definite integral and another one is indefinite integral. Definite integral is a number and represent area under the curve f(x) from x equal to a to x equal to b. Meaning here, the definite integral have limits. Okay, so for the indefinite integral, it is a function that takes the antiderivative of another function. As you can see here, it doesn't have a specific value for the x. Okay, so I'm going to show you a video on how about the different derivative and also antiderivative. Wait, I'm going to play.
We know how to take derivatives of functions. If I apply the derivative operator to x squared, I get 2x. Now, if I also apply the derivative operator to x squared plus 1, I also get 2x. If I apply the derivative operator to x squared plus pi, I also get 2x. The derivative of x squared is 2x. Derivative with respect to x of pi of a constant is just 0. The derivative with respect to x of 1 is just a constant. It's just 0. So once again, this is just going to be equal to 2x. In general, the derivative with respect to x of x squared plus any constant is going to be equal to 2x. The derivative of x squared with respect to x is 2x. Derivative of a constant with respect to x. A constant does not change with respect to x, so it's just equal to 0. So you take the derivative, you apply the derivative operator to any of these expressions, and you get 2x. Now let's go the other way around. Let's think about the antiderivative. Antiderivative. And one way to think about it is we're doing the opposite of the derivative operator. The derivative operator, you get an expression and you find its derivative. Now what we want to do is, given some expression, we want to find what it could be the derivative of. What it could be the derivative of. So if someone were to tell you or give you 2x, if someone were to say 2x, let me find this. So if someone were to ask you, what is 2x the derivative of, then I essentially ask you for the antiderivative. And so you could say, well, 2x is the derivative of x squared. You could say 2x is the derivative of x squared, but you could also say 2x is the derivative of x squared plus 1. You could also say that 2x is the derivative of x squared plus pi. I think you get the general idea. So if you wanted to write it in the most general sense, you would write that 2x is the derivative of x squared plus some constant. So this is what you would consider the antiderivative of 2x. Now that's all nice, but this is kind of clumsy to have to write in a sentence like this, so let's come up with some notation for the antiderivative. And the convention here is to use kind of a strange looking notation, is to use a big elongated S looking thing like that, and a dx around the function that you're trying to take the antiderivative of. So in this case, it would look something like this. This is just saying this is equal to the antiderivative of 2x. And the antiderivative of 2x, we have already seen, is x squared plus c. Now, you might be saying, why do we use this type of crazy notation? It'll become more obvious when we study the definite integral and areas under curves, and taking sums of rectangles in order to approximate the area of the curve. Here, it really should just be viewed as a notation for antiderivative. And this notation right over here, this whole expression is called the indefinite integral. Indefinite integral of 2x, which is another way of just saying the antiderivative of 2x.
Okay, so that's the whole definition. Can you guys understand? Can you guys hear the voice earlier?
Yes, teacher.
Okay, nice.
Yes, teacher. The video is
So-
clear.
Okay, good. So this is the notation for the integration. When you do the integration, you need to remember to always put the integral symbol over here, and then the function in the middle, and also don't forget to put the dx or dy if the slices along. So that's all my part. I'm going to pass this next to the next presenter. So that's all.
Okay. Everyone can hear me?
Yes, clearly
teacher.
can hear.
Okay, so today I'm going to start my teaching by introduce to you and explain to you guys about two types of integration of function, which is integration of exponential function and integration of natural log function. You guys still there? Hello.
Yes, teacher. Yes, teacher.
So, okay, let's start. So for my part, we'll just teach and explain to you guys. Okay. We're going to focus on integrating exponential function. So let's begin with the first rule given on how to integrate the function. So the function given is e to the power of x dx is equal to e to the x plus c. So for this function, it's simply going to equal to the same thing, which is e to the power of x plus c. You guys can see my slide.
Yes, teacher.
Okay, I will continue, okay?
All right.
So let's move to the example given on how to integrate the 5e to the x of dx. So we just need to have to move the 5 into the prime. So it will turn to be 5 antiderivative e to the x dx. So the final answer is 5e to the x plus c. Okay? So I'm going to continue my presentation by explain to you another example of exponential function. So the rule is given, which is how to integrate the e to the power of ax dx. So the it's equal to 1 over a e to the power of ax dx. So look at the example given. So for this function, we using u substitution. So how to integrate the e to the power of 2x dx. So let's say the u is given, u equal to 2x and du dx is 2. So we can get the du over 2 is 2x. So we move to the step 2. So the step 2 is we have to replace the 2x over here, 2x here with the u variable and replace dx here with du over 2. So it will turn to be like this. Okay. To integrate the function, you have to move the 2 into the front and we get 1 over 2 antiderivative to the power of u du. And the final answer will be 1 over 2 e to x plus c. Okay. Now we are going to watch a short video about integration.
We also know that if we differentiate y equals e to the power of f of x, some function of x, then dy by dx is the derivative of that function multiplied by e to the power of f of x. So again, in reverse, to anti-differentiate or to integrate something of the form f dash x e to the f of x, the result will be e to the power of f of x, and don't forget the plus c, that constant of integration again. So looking at a couple of examples, firstly the integral of e to the power of 6x with respect to x. Now the 6x here is our f of x, and so f dash of x is 6. So we know that if we integrate 6 e to the power of 6x, we're going to get e to the power of 6x plus c, using this result from above. But in the question here, we've got e to the power of 6x, not 6e to the power of 6x, so we need to divide this by 6, and so the result is e to the power of 6x over 6 plus c. In the second example, our f of x is x squared, and so our f dash of x is 2x. So again, from the result above, we know that the integral of 2x e to the power of x squared is e to the power of x squared plus c. But our question is asking about 10x e to the power of x squared, which means we need to multiply this by 5. And so the result we're looking for is 5 e to the power of x squared plus c.
Next, I will just explain to you another example of natural log function. Okay, before that, let's watch a simple video introduce about integrating of natural log function.
In these examples, we'll have a look at some integrals that lead towards the logarithmic function. Let's start off with a basic example. So we're being asked to integrate here the expression 1 over x. Now the logical thing to do would be to rewrite this in a form where it's x to a power, and that way it would allow us to go through and apply some basic integration rules. And that is that if we have any expression, such as a polynomial x to the n, what we do is we raise the power of that function and we divide by the new power. So in this case, we'd raise the power by 1 to become x to the 0 and divide by that new power, which is 0, of course, plus a constant. This does raise a concern though, because we know that if we divide an expression by 0, it's undefined, so we have a bit of a problem. What we can do though is recall what happens when we have a basic function of y equals the natural logarithm of x, and it's assumed for this video that you have gone through and seen that the derivative of that expression is 1 over x. Therefore, to integrate or antidifferentiate the expression 1 over x, the result will be the natural logarithm of the absolute value of x plus c. Now you'll notice on the screen we've inserted absolute value signs around the x. That's because the log function is only defined for x greater than 0. Now in some textbooks you'll see the solution left without the absolute value signs, and it's worth considering why that might be. So the expression might be defined such that the results for that expression are only positive values. For example, the natural log of x squared plus 1.
You guys still there?
Yes, teacher, I'm listening.
Okay, thank you. So for the next slide, I will explain to you the natural log function. So for this subtopic, we are going to talk about how to integrate function that turn into natural log function. So let's start with this rule. So okay, this rule, antiderivative 1 over x dx is equal to ln absolute value x plus c. So we can see absolute value symbol right here because we can't have a negative number inside a natural log function. So we need the absolute value. So look at this example. The example here, we just need to apply the rule into the question. So how to integrate the 2x dx? Again, we just move the constant number 2 into the front, and we get 2 antiderivative 1 over x dx, and the final answer will be 2 ln x plus c. Okay, actually the x here must have the absolute value. Okay, sorry. Okay, next. Okay, next slide. Another example of natural log function. So I will explain to you this example. Before that, look at this rule before that. For this rule, the derivative f prime x over fx dx is equal to ln fx plus c. So look at the example. We just need to apply the rule into the equation. So for the example, we also have to using the u substitution. So let's say the u is given x squared plus 2x, and we get du dx 2x plus 2, and factorize it to in bracket x plus 1, and we get du over 2 is equal to x plus 1 dx. And last, for the step 2, again you have to replace u and du for this part and this part dx, and we get antiderivative 1 over u du over 2. Okay. Okay, next, you move the 2 into the front and we get 1 over 2 antiderivative 1 over u du. So for the final answer, the final answer for this question is 1 over 2 ln bracket x squared plus 2x plus c. So
in this tutorial, I'm going to discuss integration by substitution, or called u substitution. I'm going to find the integral of this function, and the final answer looks like this. Don't run, hang in there. I'm going to walk you through this step by step. If you look at this problem, you'll find that there's a relationship between x squared plus 1 and 4x. And in fact, if I take the derivative of x squared plus 1, it's kind of like 4x. So the derivative of x squared plus 1 is 2x. And if you watch a couple of these examples, you'll kind of get the hang of this. So now let me do a u substitution. So u is equal to x squared plus 1. The derivative of u is du. So if I take the derivative of x squared, that's 2x, plus the derivative of 1 is 0. The derivative of any constant is a 0. So now du is equal to 2x times dx. I'm going to solve for dx. I'm going to put it right there. I multiply both sides of the equation by 1 over 2x. And notice on the right-hand side, these 2x's cancel out. Now I have du over 2x is equal to dx, and I'm going to put it right there in a moment. Let me copy this 4x divided by the square root of x squared plus 1 over. Right where this x squared plus 1 is, right there, I'm going to put u, like that. And where there's dx, I'm going to put du over 2x. Now, if you notice this 2x and this 4x, the x's cancel out. And I'm left with 2 divided by the square root of u du. This looks like something I can actually integrate now. I'm going to move this up and give myself a little bit more space. I'm going to factor out to 2. And this square root of u is equal to u to the 1/2 power. So I have 2 times the integral of 1 divided by u to the 1/2 power du. I can also write this as 2 times the integral of 1 times u to the negative 1/2 power du. Now I'm going to take the antiderivative of this. So I have 2 times 1 times u raised to the negative 1/2 power plus 1, like that. I'm adding 1 to the exponent. 2 times 1 is just 2. Negative 1/2 plus 1 is 1/2. And when I take an antiderivative, I take this power, this new power, and divide by that again. So it's divided by 1/2. 2 divided by 1/2, 2 divided by 1/2 is 4. Now I have 4 times u to the 1/2 power. And if I put the u back in, which is x squared plus 1, plus some constant, don't forget your c, plus a c, that's my answer right there. Let me get rid of everything else and you'll see, there we go. Now I'm going to check my answer. You should always check your answer by taking the derivative of this bad boy down here. The first thing you can do is just lob off that c, because the derivative of any constant is nothing, 0. Now I use the chain rule. I take the 1/2 power and multiply it in front of everything. So I move it in the front times everything, and I subtract 1. Now I take the derivative of the inside, which is 2x. 1/2 times 4 is 2. The new exponent, or the power of x squared plus 1, is negative 1/2. And I just pull this 2x down. I continue. 2 times 2x is 4x. This is looking up. So now I have 4x times x squared plus 1 to the negative 1/2 power. Now I have 4x divided by the square root of x squared plus 1. Anything raised to the 1/2 power is the square root of, and since it's a negative, I put it on the denominator. So look at that. That's what I'm talking about right here. That's the right answer. And here you go. Here's the complete problem worked out, the integration of it. And remember to share the knowledge, share the love, Facebook, Google+, and Twitter. Links to other videos and examples below, and subscribe, and please like me, please. I don't have any friends either. Please. Please. Please.
Are you guys understand what I did explain to you?
Yes.
Yes,
Okay.
teacher.
So I think that's all. So okay, I think that's all for the two types of integration that I explained to you. That is integrating the exponential function and integrating the natural log function. So we will continue this class with the next presenter, and thank you. Thank you, class.
You're welcome, teacher.
Okay, now we will continue to our next session. After you have learned about the integral exponential function and integral natural logarithmic function, now let's test your skill, okay? Here are some exercises that you need to do. Okay, wait, I will open my PowerPoint, my slide. Okay, here are some exercises that you need to do. Okay, I want all of you to answer this question, and I will ask maybe some of you to answer the question and show the working step. Okay, you are given 4 minutes to solve the first two questions about the integral of exponential function, and your time start now. You may discuss with your friend. Okay. Okay, the 4 minutes have finished. Okay, let's see who are voluntarily want to show their working step. Okay, please upload your answer in our WhatsApp group and I will check it. Okay. Alright, let's see.
Already uploaded, teacher.
Okay. Okay, here we got one answer from our friend Tina. Okay, let's check one by one. Is it correct or not? We will compare to the solution in the PowerPoint. Here is the solution. Here is the answer from your friend. Can you see? Can you see my arrow? Okay.
Yes, teacher.
Alright. Okay. Okay. Let's check Tina's answer. Here. Okay. The answer is correct and the step also correct. Okay. Very good, Tina. Let's see for the second answer given by Anissa. Anissa, right? Okay, let's see. Wait, still loading. Okay, here are the answer given by Anissa. Let's check the solution. Is it the same or not? Okay, here are the solution. For the second question, okay, let's check. Okay, the answer is correct. 2x minus 3 exponent x plus c. Okay, the step also correct. Okay, very good, Anissa. Okay, thank you for answering this question. Okay, we will proceed to the next question. The next question is about the integral of natural logarithmic function. Here are the two questions. Okay, you are given 4 minutes to answer both questions and please upload the answer in our WhatsApp group. Okay, your 4 minutes start now. Okay, 4 minutes have finished. Okay, let's see. We got one answer from our friends. Okay, here is from Najmi. Okay, let's see. You have done both question 1 and question number 2. Can you see it? Please respond. Hello.
Yes, teacher.
Yes, teacher.
Yes, teacher.
Yes, we can see it, teacher.
Okay. Okay. Here is the solution for number 1. Okay, exponent integral 3x square plus 1 over x cubed plus x dx. Okay, let's check the answer for the first question. Okay, the answer is correct. Ln x cubed plus x plus c. Okay, let's check the step. Is it correct or not? Okay, yeah. You need to replace with u. Okay, correct. Number 1 also correct. Okay, let's check for the next question. Number 2. Okay, number 2 is integral of 1 over 4x plus 1 dx. Okay, the answer also correct. 1 over 4 ln 4x plus 1 plus c. Okay, very good. Okay, let's check for the step. Okay, thank you. Okay, very good, Najmi. Thank you for your answer and thank you for your cooperation. Okay, let's check. Okay, here are the solution. I will give the slide to you in our WhatsApp group. Okay.
Before end our teaching and learning, I will test your level of understanding about this topic with Kahoot game. It is a game time. Time to show your skill. I will share the link for game in WhatsApp group. I hope everyone join this game to know our understanding about this topic. Are you ready, guys?
Yes, teacher. Yes.
Yes, teacher, sure.
Yes, teacher.
For your information, this game has
Yes.
3 questions and who can answer all 3 questions correctly in a short time will be the winner of this game. You only have 3 seconds to answer each question. You can take the 3407 345. Are you ready?
Yes, teacher. Yes.
Hello? Yes, teacher. guys. You all have 30 seconds to each question, to answer each question.
Okay, teacher.
Can I start now?
Yes, teacher.
Okay. Good luck, everyone.
Okay, teacher.
Okay. Wow. Congratulations.
Thank you.
Last game. Congrats everyone. Thank you join this game.
Thank you, teacher. Siapa menang?
Mira, Tina, and Mimi. Congratulations, you all.
Thank you.
Thank you.
Thank you, teacher.
Thank you, teacher.
Thank you. Congratulations to the winner. You prove that you give attention and fully understand what you are taught. And those who do not win, the congratulations as well because you managed to answer all of the questions. Hopefully, this game will be an exercise for what you learned today. Before I forget, everyone can join Google Form link or scan this barcode to reflect on our teaching and learning. Only 4 questions in Google Form, which is name, level of understanding, comment if you do not understand and suggest improvement. And don't forget to submit. Hopefully everyone can take some time to get us feedback from you all. Thank you for today, guys.
Okay, thank you too, teacher.